Okay, so as in the last video, we completed discussing about all the concentration terms, right? We initially discussed the concentration terms which were related to volume, and then we discussed concentration terms which were related to mass. The concentration terms which were related to volume were volume by volume percentage, weight by volume percentage, molarity, and normality, right? In this, on the other hand, we discussed some concentration terms which were related to the mass, and those were weight by weight percentage, molality, ppm, and ppb, parts per million and parts per billion. We discussed about all of these in very detail. Now we are good to go with the vapor pressure. Before going towards the vapor pressure, we must understand what is evaporation. Since if we will not get the term evaporation, we will never gonna get what actually evaporation is. All right. So we will gonna understand evaporation first. We will discuss evaporation first. Now see, I'm making here two beakers so that it might become easy for me to explain you guys, and it would be easy for you to understand as well. Now see, I have two beakers here, right? Wait for it. This is the first beaker, right? And this is water. Um, this water, right? This entire is water. This water, okay? Let me make it blue. Okay, so this is water we have. Now inside this water bucket we have molecules, right? Here we have some molecules, and we have here molecules as well. Now see, the molecules which are on the surface are called surface molecules. These are surface molecules, right? And the molecules which are here are called bulk molecules. Bulk molecules. Now see, always surface molecules would be evaporate. There is no any case in which bulk molecule would be evaporated. There is only a case where surface molecule would be evaporated. Why will they be evaporated? Let's discuss that. Since you can see here they have attractive forces, right? And all are downward. They are less attractive forces actually, right? They are less attractive forces. But if we see the bulk molecule, they have more attractive forces. From every side they have attractive forces, right? That's why this would not be evaporated. However, surface molecules would be evaporated since they have less attractive forces. So what we can write about surface molecules here, they have less attractive forces, less attractive forces. Okay, so the first is they have less attractive forces. Second, these molecules would be evaporated. Or you know what, when there are less attractive forces in these molecules, which means they'll be skept, right? They'll be skept. They'll be skept. So these molecules would be skept. This is simple what we call the evaporation, right? The escaping of the surface molecule, since they have less attractive forces. So the escaping take place, and because of that speaking is what we call the evaporation. Right? Now let's suppose, what if this bucket was closed? Now see, evaporation would always be happening in the open container, right? But what if we had closed bucket? Let's check that case now. So this is closed bucket. Here again we have those molecules. Okay. Here. These are surface molecules and these are bulk molecules which would not be, of course, evaporated, right? Okay, so now we know that these molecules would be escaped since they have less attractive forces, right? Because they have less attractive forces, that's why they would be escaped. But now see, this time the container is closed. So how will how will these molecules be escaped from here? So that's why these molecules would not be escaped from here this time. They won't be expect won't be escaped. However, they will gonna create a create pressure, and this is what we call the vapor pressure. Very simple, right? Vapor pressure. This is what we call the vapor pressure. Now see, what's the definition of vapor pressure? The definition of vapor pressure, they state that the pressure just above liquid surface, the pressure just above liquid surface, which means here, right, the pressure just above liquid pressure. Or you can say, we have a second definition for it as well, where you find, now see, here are two, um, what process take place. What those processes are, let me tell you that. The first is evaporation, as I told you, escaping of the molecules, right? Evaporation. Secondly, condensation. Now how condensation? See, in this case, we don't have any condensation since here only evaporation takes place. The molecules escaped from the bucket since this is open container. But when we took closed container, here evaporation is taking place, which means the molecules of the water are changing into gas. But now that gas would be changed into water, that's why they create a pressure, right? So this is what we call the evaporation, the changing of the state from gas to liquid again. So here was gas, right? But it is now changing into liquid. So this is what we call the evaporation. So where condensation and evaporation are equal, at the equilibrium point, the evaporation and condensation, when they both get equal, and this is what we call the evaporation, or a pressure just above the liquid surface. Okay, so in the today's video, what we have discussed, we have basically, initially we have understood about evaporation, what evaporation is. Then we discussed, uh, or we took an open container, since vapor pressure is just made in the closed container. Vapor pressure would not be made when you take open container. This is a limitation. You always need to take a closed container rather than open container. If you're going to take an open container, the molecules would be escaped from the container, and that would be evaporation. But when you take closed container, the molecules would not be escaped. They'll create a pressure just above the liquid surface, and this is what we call the vapor pressure. So vapor pressure is always made when you take a closed container. All right, so this is all for today. In the next video, we're gonna discuss factors affecting vapor pressure. What are the factors that affect vapor pressure?